Good day, guys. Okay, how are you doing today? So we continue from where we stopped last time. Last time we're about to implement this binary counter that we have here already. We have the binary counter here counting already. So, but now I'm going to stop it. So I'm going to start again from I told you that instead of us writing the binary forms of the code, you can easily use a decimal number, which is quite easy for us to read as human being, compared to be using a 0 and be operating at 0 and 1 level. Now let's try to create a value let's just create a value, the hexadecimal number value. So I have them stored already somewhere. Now constant int, and that is a LED values array of 15, going to be single array this time around, not double array. So we already store them inside it to avoid the use of double arrays. So let me just copy the values and bring them to us. Trying to copy it. Okay, let me cut it a little bit so I can see it clearly. All right. Okay, here's the value now. Then we have, this is for 1, 2, 3, 4, 5, 6, 7, 8. Now this is hexadecimal, not binary number, not normal decimal number. We know that our binary ends at 9 or decimal ends at 9, but to indicate it in our code, either C, C++, our programming languages, anytime the compiler sees something like 0x, it means that you are talking about hexadecimal values. If you see 0b, for instance, like this, with the binary number, and you put 0b in front of it, just put 1, 0, maybe 0, 0, 1, 1, 1. 0, oh, this is binary. I put comma. Again, you see this one as binary number. That this user has entered a binary digit number. So, in case you also put 0 in front of it, maybe you are trying to enter an odd number. Understand? Normal decimal number is sometimes you just put the normal values without putting anything either in front of it. But by the time you put 0x in front of it, it's seeing it as hexadecimal number. And we have our what? OXA, A, B, A for 10, B for 11, C for 30, so hexadecimal values. This is very cool. I think we're used to this, right? Then we now the same, our code still remains the same from our previous video. Then we now also, but here is where we have some changes here. I'm going to have some changes here. You know, the other time in this code here, we turn on the 0 and 1 bit, either to on and off with this code. But this time around, we're going to do one thing by converting it to what? To bit. Just into bit, maybe just bit. Then we convert it to either 0 and 1. And how do we convert it? Just let's follow the code. We get this number. We shift it to the right shift. That's right shift to the right in the number of what? The I places. Then, and we hand it with what? With 1. So, the more we go, the more 0 we have. We shift this one in 4 places till we get, and then we now add it with 1. So, in the same number decimal values. All right, let's go on. Let's check. Now, how do we, let's demonstrate this. In our, let me open my VS Code to demonstrate for us this. Now, for instance, if my 5 is, I'm shifting this in 5 places, maybe shift it to the left in 2 places and hand it on. But let's just do one thing. I want to print something in C. 5, shift into 2 places. Am I going to get in my code? Let me run it. I'm getting 1. Okay. Therefore, let me now do something and it with what? Maybe 1. Either we get 0 or 1. And so get 1. Okay. Let me add it with, let me just do it with 1. we get 0. So let me also end it with what? With 4. So the value we can get is either 1 or 0. So with that, now let's continue with our code now. Here again, we're going to change this total value to this value. Remember one thing, in digital write, it either be what? High or low, up or down, 1 or 0. So just put the bit here. After that, what else we need to do? So our code still remains the same. Let's compile. Let's save this code. Let's save it. File, save as. Let me save it inside. Then we create a bytecount. Let's just name it as bytecount code. Let me name it as bytecount and code 2 as second version of it, B2. So it's been saved now. Let's compile. No error. Then let's export the sketch. But in case you are using the device straight, so you don't need to export it, just upload, just click on here, upload after selecting device. So just sketch. Okay, let me export the binary compile. Now let's come to our code here. Let me run it. Same circuit still remain. Load the firmware. Coming to bytecount code, build, bytecount code 2, build. We copy the S file, then we run it. Our one is starting from here. Can you see there's discrepancies in our wiring system? So we can also alternate it from here by changing the wire, by putting this one to be 5 pin. But you can also do the same thing in our code by just modifying our code straight and change from the code straight instead of us doing that. Just changing the wire. You can just comment here. From here, you can just say, okay, let me just copy this. You can just comment it and you see different. Just assign I to be what? 15. Then if I is greater than. Let's just do this one in the reverse form. I is equal what? Greater 0. Then it should be -1. Just or minus. Can also just be minus. So let's compile. Let's export the binary, compile binary. Then we can easily, let's now load our, let's reload firmware. Let's compile 15. Oh, it's descending, it's slipping down in the descending order. Okay, it's counting down in the descending order. So let's try. Okay, we can just change the wire then. Just change the wire. Sorry for that. That means our other code as well. Let's compile. 15, 14, 12, 13. Now let's compile our code back. After compile, export the sketch. You can also set it from your setting to export the sketch somewhere. So export, compiles binary. Now let's come back to our code. Let's reload the last reload. Let's 1, 2, 3. Now we are fine. We are good to go. Now, but let's test also in our PICSimlab, now PICSimlab. Let's see how it behaves there. I will open it now. So let's just try to, let me copy, let me bring this my Arduino code. So let me just terminate. Let me close this ones. Arduino close it. It's not closing. Just okay, it's here. Sorry, there's one pop-up something here. So delete. Or virtual terminal delete. So now let's add. We have our Arduino board here. We have our Arduino board here. Now let's try to load the code. Before then, let's bring out our what? 4 output LED pins. LEDs. Let's bring out. This is 8 in number. Let's change it to just 4. Just give me 4. And then the pin LED one go to pin 2, pin 3, pin 4, pin 5. It's pin 2, pin 3, pin 4, pin 5. Then you can change to green or light anyone. So then we have it there. Move to the middle. Move. Then we compile we load our firmware. Come here. Let's load our S file. Our S file will be inside this. Then you can't go to build Arduino. Yeah, I think we have the second one now. 2. Count it down. So the first one is working for. Let me minimize this. Just press the reset button. Wow. And I'm loading the load S file. We need to RTD. Vacant code. And the 2.uno. This is the first one we even did. 2, 3, 4, 5, 6, 7, 8. Oh, 2, 3, 5, 6. This is counting up to 7. I'm not getting to 15. It's still not part of it. So I'm getting some error here. Oh, this is 2 here. Into. Oh, this is pin 2. This is pin 2. Pin 3. Pin 4, pin 5, D4, D5. Okay. Alright, now. Here. We're good to go. Reset. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Fine. So this is our form code. But the previous one, how to do the rewiring? Okay. Then before I move from this, so let me just add one of the things I also want to add with the code, that is adding the analog. In 2 lectures behind, we talk about adding the rheostat, that is with a code, that the potentiometer to be able to control. Let me now add the potentiometer with this port. Potentiometer, we have the potentiometer here. Imagine you want to add potentiometer to be able to adjust the volume control. Want to adjust, the more we adjust it, the more. So at what scale you want to adjust it. So to be able to get each value at a time, then we're going to attach to the analog. We have the analog section of the Arduino Uno. The A0, A1, A2, A3, A4, A5 is where we are going to attach. Either here it can be 0 or 1. This can be VCC. We have 3 terminal in our port. So the first one can be 0, or this one can be VCC, or can be what? Can be VCC and the GND. We attach the VCC here. That means our fixed voltage will be voltage, for example, for our source. Check for our source voltage at 5 volt voltage, and get it down here. You can also put your GND. You can also get your ground from the GND, or you attach it to the ground here. You can just put, but this, the middle one, the middle pin is where our data is going to go to. The middle pin go to the what? A0. Then we are fine now. So we have 1 kilo ohms potentiometer. We want to use it to increase, to count the binary. We want to use it to count the binary from 1, 2, 3, 4, 5 to all to get to 15. So now let's scale this to 15. So we're able to get it up to 15. We come to our code. We modify our code. We modify our code by also including a button called, we got int port pin, potentiometer pin equals, I can make it unsigned, so we don't want it to get to negative. Unsigned. So we don't want it to get to negative side. So we can just make it what? Maybe assigned pin what? Pin A, that is A0. Then we can now terminate it here. Let's give a space to this. Okay. Then we also assign a pin mode here to be what? Pin mode. Whereas it's an input. So that is an port pin as input, not output this time around. So we have it as inputs. What else do we need it for here? But here we're going to be counting. So what's having a for loop here? We're going to remove this for loop, comment it out. Then before we're going to what? Assign a value to it. Port value. We're going to get the port value to it. Port value unsigned. Int port value. The value from the potentiometer. Go to 0 at default one. Then we can now get the port value equals. We use the map function to get the analog signal. But first, let's read. Let's first read the signal before we use digital write, digital analog read. Now let's read analog. Let's read the signal, the data coming from it. We're going to use a function called analog read. From which pin? Ports pin. We're reading from A0, pin A0 now. Then let's just get our value. Int value. So we get value from it. Get it through the help of the map functions, containing like 5 parameters. So the first one is our port value, what we are reading. And the second one is, because ADC, majority of the ADC readings are all start, but it's 2 raised to power n. The formula is 2 raised to power, maybe get the voltage via VCC over 2 raised to power n minus 1. 2 raised to power, majority of the ADC readings are in what? Are in 10 bit. So it's going to be 2 raised to power n 10 minus 1. That is 1024 minus 1, which should give us 1023. So from 0 to 1023. The reason why we have minus 1 there is because we are starting from 0 value, not from 1 to 124. So that's the reason why we have minus 1 there. Then we have the value here from that will be 0 to 1023. How many value are we expecting from here? That is from 0 to 14. Then we should have this value here now. Then we get the value here. So we scale the value, we get this value, we get the value now. So we turn on the value we get from here will be what we're going to assign to it. Let's see. Display. What value. Let's just put that value here. Then we delay for how many? 1000. Let's see. Hope there's no error here. Let's firstly run it before we come back to explain the code. Compiled. That's code 2. Then we come back to our code. Let's put on the voltage here. Let's set the voltage here to 5 volts. Then let's load the, we export it. Let's export the code. Let's export binary compile code. So now let's reload firmware. Let's run it. Our code is running now. So let's run it. 1, 2, that is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. Until we get to the last one, which is 15. It's not doing that. Oh, sorry. The last it should be up to 15. Sorry, it will reduce it will get the -1 by itself. What is the code there? Let me just make it to 15. So you can also get the serial monitor to see what the value is being attached to. Let's compile it. Let's also add the serial monitor to it. To add the serial monitor to it, come to this. You used to see the value as they go on serial. Serial terminal. This is terminal here. So imagine, okay, the serial terminal will go to pin 1. You can see transmission and receive. Let's put this and just put it here. The transmitter here will go to receive, which is pin 0, and the receiver will go to what? Oh, don't want it to fall in line with that. And see the wiring. So also have this. Good. Now want to see the value here. So can you see the value? Can you see the value as it come on? Okay, let's compile. But before then, we have to also make adjustment in our code. The serial monitor enables us to monitor what is going on in case you want to display some kind of signal from want to see some value you want to see. You can also pass in the value to read. There's a function also made for read. In our setup function as well, we have what? Serial.begin. So that's what starts. That is configure. That is configure serial monitor. So we have serial control space dot begin at beginning. And take a baud. The standard number is 9600. The baud is the baud rate. The baud rate. That is the baud rate value. So just don't get that. That is the baud rate standard value. So, and we have, then here we cannot display the value that we are having here. Then this one can just wait for a minute seconds. That is serial. That is no motion. Dot write. That is value. Let's just see. Done. And that's done. Let's compile our code. Sketch. Export compile binary. And that is export compile binary. Okay. Okay, we enter into our binary code now. So you can compile. You can see we're not seeing anything from our serial monitor yet. So I've not reloaded last frame something. we compile the code. Now we have this. We have seen something displayed here, but doesn't make sense the way what we are seeing. It's in ASCII format. I just change it to the decimal values. And you see 005. Well, you see we have 5 here. We are seeing 5 here. And see, you can see it here clearly. I can see 5 here, the value being displayed. You can see 7, right? You can see 8. You can see the value being displayed. Okay, thank you very much, guys. So please, in case of any question, please, I'm open to questions. You can also try the same thing with your, because of time, also add it here, the same thing with our PICSimlab, and also the same thing with it by coming to your virtual terminal. Just configure it the way we do. Input, come to your potentiometer, potentiometer, this one here. So potentiometer, this one. We delete this one. Your rotatory. Let's pick the one that is rotating. So you can just add it, please. In case you have any issue, please just let me know. You can also get the properties and adjust just only one. Just need only one. So in case of any issue, please let me know. Configure them. I will see you. Yes, move up. Yes, I want you to demonstrate it yourself. I want you to load the code, configure it yourself, try it out, and I will see you in the next video. Have a wonderful day. Bye-bye.